Okay guys, sorry that I am not here today, but I wanted to still be able to go over the notes for section 2.8 factoring binomials. I feel like you guys can still do this even if I'm not here, because we've already actually talked about factoring binomials when we multiplied binomials together. This is the difference of squares theorem. Okay, so for difference of squares, we want to make sure that we're checking for three things. Okay, so difference of squares, if you remember, we talked about that a little bit before. The three things are, first, always a greatest common factor. So if I have a greatest common factor amongst the binomial, we want to make sure that we factor that out. The next thing that we need is we need a perfect square. A perfect square for, well, there's only two terms because it's a binomial, but the first and the last terms. So remember, perfect squares are 1, 4, 9, 16, 25, so on. Those are the first couple of perfect squares. But also we have perfect squares if we have x squared, because that is equal to x times x. If we have x to the fourth, that's equal to x to the second times x to the second. If I have x to the sixth, that's equal to x to the third times x to the third. So basically any sort of even exponent, or one of the 1, 4, 9, 16, 25, 36, so on and so forth, these are your perfect squares. Okay? Let's write that there. Perfect squares. So that's what we're looking for when we do a difference of squares. And then I am looking also for subtraction in between the two terms. Since it's binomial, two terms, I want subtraction. So what you should see is oops, sorry, didn't mean to jump. You should see this. You should see a term squared subtracted another term squared. And remember what happened was this became a plus b, so I had 1 plus and I had 1 minus. So a plus b times a minus b is how that factors. So in yesterday's lesson we talked about factoring using the AC method, where we multiplied our a and c and we found pairs that added to the middle term and multiplied to the last term. Essentially it works the same way, only it's just kind of, it's a trick, I guess you can say, because it works faster because you always are dealing with perfect squares. Okay, so if you look at the first example, the coefficient of x squared is 1 and the constant is -9. So if I look at those values, 1 and -9 don't have anything in common other than 1, so there's nothing to factor out. So there's no GCF. So that's the first thing to check for. The second thing is check for perfect squares. X squared, that was one of the ones that I listed up here. 9, that's one of the things I listed up here. Subtraction in between the two terms. Right there in the middle I have subtraction. So the fact that I have squares and subtraction means that this is going to factor into a plus b times a minus b. Well, what is the a value? If x squared is a squared, I'm really taking the square root of x squared, which is just x. So x is your first value. For the second value, you're taking the square root of 9, which is just 3. So how is this going to factor? X plus 3 times x minus 3. And there's our product of a binomial. Now, remember, yesterday we talked about has to add up to the middle term. So let's say that we write this in another way, where it's x squared and then I have -9. Remember, the middle term had to have an x. Well, in this case, if it's not written, it's 0. So if I do a, which is 1, times c, which is -9, and I have -9 being multiplied, but adding to 0, what's going to multiply to -9 and add to 0? positive 3 and negative 3. Positive 3 times negative 3 is a negative 9. Positive 3 plus negative 3 is 0. So there again is my, I could write it as x squared plus 3x minus 3x minus 9. And I could do my factoring by grouping. So I take out an x and left with x plus 3. And I take out negative 3. And I'm left with x plus 3. So I have x minus 3 times x plus 3. That's the long way, okay? So it's easier to recognize when you have a squared term and a squared term. Just becomes x plus 3 times x minus 3. Okay, so don't do the long way. If you recognize patterns, then do the short way and break it into a difference of 2 squares. Okay, so looking at number 2, if I look at x to the 4th, that's on that list. Okay, and I look at y squared, that's essentially the same as an x squared. It's just replaced with a y. I don't have a GCF other than 1. So if I'm taking the square root of x to the 4th, that's x to the 2nd. If I'm taking the square root of y squared, that's y. So a plus b, x squared plus y, a minus b, x squared minus y. Final answer. Okay, so for examples number 3 and 4, notice how I do have a perfect number 4, and it's a coefficient. In 4 and 25, do they have a GCF? They do not. So let's try and take the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. The square root of 25 is equal to 5. So I have 2x plus 5 and 2x minus 5. All done. And lastly, check 2 and 200. Yep, they do have a GCF. So let's factor out a 2. So I divide each of these by 2, and I'm left with x squared minus 100. X squared is perfect. 100 is perfect. The square root of x squared is equal to x. The square root of 100 is equal to 10. So I still have the 2 out in front. X plus 10 times x minus 10. And there's your final factored answer. Okay, so that's the front side. If you guys could take a second and we'll flip over the back side, because the back side is our graphic organizer that has everything we've done with factoring so far. Okay, and so here's how you can tell what to do when. So first, with factoring polynomials, look for the GCF, always. So that always has to be your step 1. Okay, so this is your step 1. Always look for your GCF. Factor it out. Remember, we take it out and we divide it out of each term. Okay, if there are 2 terms, look for the difference of squares. That's your a squared minus your b squared. So 2 terms after you look for your GCF, try and get your difference of squares, your a squared minus b squared, which is equal to a plus b times a minus b. Okay, so if I have x squared minus 64, 1 and 64 don't have anything in common. Square root of x squared is just x. Square root of 64 is 8. So x plus 8, x minus 8. If I look at 18m squared n minus 2n to the 3rd, well, that has a lot of stuff, but it has a 2 as a factor of 18 and 2. I also see both terms have at least one n, so I'm actually going to take out a 2n. I'm going to divide everything by 2n, divide by 2n. In this case, I'm left with 9m squared minus n squared. Check for squares, perfect squares. 9's perfect, m squared is perfect, n squared is perfect. So I have 2n out in front. Square root of 9 is 3. Square root of m squared is m. Square root of n squared is n. So I'm going to do plus n and 3m minus n. Okay, that's a more complicated example, but it shows that you can still factor after you've factored out a GCF. So this first one had no GCF, the second one had a GCF. Okay, if there are 3 terms, now we're looking at a trinomial. Again, first factor out a GCF if you can. Sometimes the trinomial has 1 as a coefficient, sometimes it has a, or a number as a coefficient. We're going to do the same process, but for like the trinomial, find the factors of c that add up to b, because if I multiply 1 times c, you're just going to get c back, okay? So here, x squared, do they have any GCFs? They don't. So I'm going to multiply 1 times negative 42. So I do like this x method. So I have negative 42 over here. That's my multiplication. And then my addition is down here at negative 1x. So what multiplies to negative 42 and adds to negative 1? I know 6 and 7 are factors of 42. I need one of them to be negative to multiply to give me a negative. I also need to add them and end up with a negative. So if I do negative 6 and positive 7, I'm going to have a positive 1. So the 7 has to be negative. So in this case, I have x squared minus 7x plus 6x minus 42. Find the GCF of the first 2 terms is x. So I have x minus 7. Find the GCF of the second 2 terms, which is 6. I have x minus 7. So how does that become? It becomes x plus 6 times x minus 7, which if you look, 6 was one of the factors and negative 7 was the other factor. Okay, so it ends up being that way when your leading coefficient is 1, but stick with factoring by grouping since you are familiar with that and we've done so much practice. Okay, then looking at the second one, I'm going to switch colors just since we're getting a little tight with space here. So I have 2w, 20w, and 50. They have a factor of 2, so I'm going to pull out that 2. So I have w squared plus 10w plus 25. Okay, so don't count this as your leading value, count your 1 as your leading value. So a times c is 25. I'm going to do that over here. So I get 25, and then my b value is 10. What multiplies to 25 and adds to 10? That's easy. 5 and 5. So keep your 2 out in front. I have w squared plus 5w plus 5w plus 25. Group them. And so you have your 2 out in front, factor out a w times, sorry, that 2 is out in front of everything, w plus 5, and factor out a 5, and you get w plus 5. So really you get w plus 5 and w plus 5 with a 2 out in front. Now, if it's the same factor twice, no harm in writing it as w plus 5 to the second power. Final answer. Okay, the second one is a little bit, well, basically the same if we're doing it the same way. This just has leading coefficient that's not 1, but 30, negative 27, and 6 all have 3 in common, so I'm going to factor that out. I have 10x squared minus 9x plus 2. Multiply AC, so 10 times 2 is 20. That goes in the top. Negative 9 goes in the bottom. What multiplies to a positive and adds to a negative? Only way to multiply a positive but still have a negative is to have a negative and a negative. So now, let's just look at factors of 20. 10 and 2, no. 4 and 5. 4 plus 5 is 9. Negative 4 plus negative 5 is negative 9. So we have our answer there. So take 3, write this as 10 x squared minus 4x. It doesn't matter the order that you write it. It should work out either way. And then plus 2. So we're always writing what was in the original. Okay, so group it. I'm going to change colors here. Oops, undo. Group it, group it. So the 3's out in front. I can factor out a 2x. So I get 5x minus 2. Negative 5 and positive 2. So let's take a negative 1. So then I get a positive 5x and a minus 2. And so now 3 is out in front. 2x minus 1 is one factor, and 5x minus 2 is the other factor. Final answer. Okay, so 3 terms you factor by grouping after you're multiplying your A and C. Okay, and then 4 terms, this is always going to be grouping. So if we look GCF first, 2, 1, nope, then that automatically disqualifies it because it only has 1. So let's group these and group these. So if I take, this has an A to the third, A to the second, so I'm going to take an A to the second, and I should be left with 2A minus B. And over here, 10 and negative 5, I have a 5, positive 5 that I'm going to take, and I'm left with 2A minus B. I know I did it right because my 2 parentheses terms match. So A squared plus 5 times 2A minus B. Okay, so those are all the factoring methods that we did. 2 terms, most likely difference of squares. 3 terms, the trinomial. 4 terms, it's grouping. Okay, so this is a good chart to recognize. Alright guys, I'm going to have them pass out the review right now, so after you're done with filling this in, go ahead and start your review. Test is on Friday, and I'll see you tomorrow.